Hey everybody, my name's Ryan Houghton. I'm a senior here at Boise State, and my major is Business Economic Analytics, and this is my senior capstone project. So for my senior capstone project, I decided to take an econometric approach towards the game of baseball and see whether batting or pitching is more significant and more important to winning games. So before we actually get started, I'd like to go over some key talking points that I'll hit on throughout my presentation. So first I'll start out with an introduction, which consists of why I chose the topic, why it's important to the sport of baseball. And then I'll get into my literature review, which goes over the most important papers that inspired my project and their differences and similarities to my work. And then I'll get into a data description, which is how I got the data, what the data consists of, and then I'll describe some of the more important variables that I'll use in my model. Then I'll go over my methodology, which is how I built my model, some of the decisions I made with including variables, and some variables I decided to not include, and why or why not. And then I'll get into my results and findings, which is just pretty straightforward. It's what I found with my model. And then the last part, I'll talk about my conclusion and discussion, which goes over my recommendations that I found with my work and some of my work's limitations. Okay, so why did I choose baseball? Well, for many years as a child, I actually played the sport almost all the way through high school, but that's beyond the point. I primarily chose this sport over others just because it is the most analytically driven sport out there that I could find. It's a very numbers heavy game. Everything from on the field, a lot of the decisions that are made with what you'll do in a game or how you're going to build your team. Those decisions are made oftentimes with analytics and numbers and statistics. And the sport has a ton of readily available data and stats too, which was great. Which leads me to my research question, which is what has more of an effect on winning baseball games, batting or pitching? Now, if you know anything about baseball, you know that baseball is a two-dimensional sport. It's separated between playing offense, which is batting, or going and playing defense, which is pitching and fielding. So I was intrigued to see what's more important, like which one should, if I was someone building a team, what should I prioritize more? Should I go towards more of building my team around having strong pitching, or should I build my team more around having a strong offense that can hit? Now, I did some research on the internet and I found similar research, which I'll touch on in a little bit, but I couldn't find anything that could definitively tell me what is more important, batting or pitching. So that's another reason why I really got into this topic. But that leads me to my hypothesis for my research question is I believe hitting will have a slightly more important effect on winning games than pitching does. My reasoning for that is, you can prevent the other team from scoring runs all you want, but at the end of the day, you still have to score points or runs. So now on to the literature review. So I'm going to be talking about the two most important papers that influenced my research and work. While there were a couple more papers that I'll end up talking about in my paper, these were by far the two most important to my research. So the first of those is called The Determinants of Baseball Success, an Econometric Approach by Jacob Andrew Laurie. And the second paper is called The Econometrics of Baseball, a Statistical Investigation by Mary Hilston Keener. So for this first paper, they wanted to determine what are the exact statistical determinants for winning baseball games in Major League Baseball. Now to do that, they used a data set that consisted of every single team from 1985 through 2015. So there'd be like multiple of the same organization over different years. So say there's the 1986 Seattle Mariners and there's also the 1987 Seattle Mariners and so forth. Each team has a new entry for every year, so that left them with a total of 900 different teams to look at, and all those stats were backed by thousands of different games. So what they were looking at was four different statistical categories to look at what are the exact determinants of winning a baseball game. So they looked at batting statistics, pitching statistics, and fielding statistics, and they also looked at salary, so like how much a team spends and how much that affects their winning. This was a little bit different than my research because they wanted to look at what exact statistics determine winning, whereas more as I wanted to look at like which subcategory between batting or pitching is more important. So to do this, they used a standard OOS multiple regression analysis. It was a little bit different because they put all the statistics for batting, pitching, and fielding into a matrix, which is a little bit more advanced or different than what I'm accustomed to. So that was a little bit different than what I did. But here is the model. So as you can see here, in the model they have batting, pitching, and fielding, where it says that represents a different matrix for each subcategory of stats. So say for batting, that represents a matrix that has a bunch of different batting statistics within it, such as like batting average, home runs, doubles, RBIs, etc. Same goes for pitching and fielding. You can also see they have team salary in there as well, and a couple fixed effects there at the end that help adjust for fluctuations between year to year and player to player. And now they have all of that regressed onto wins, which actually allowed them to see what the specific determinants for winning games in Major League Baseball were. So they actually ended up finding that salary did not play that much of an effect on the total amount of wins that a team had in a given season as they originally thought it would, and they also found that hits, total runs scored against, walks, and home runs played the largest determinant to winning baseball games, and they also found that strikeouts are not as detrimental as they had initially believed. So this next paper is actually super interesting and a little bit different in that they tried to predict all the teams' wins for an upcoming season using their previous season statistics, and it was super interesting because they didn't necessarily use like performance-based statistics, like say hits or like home runs, for example, but instead they used variables that were different in that they used like average age of their pitchers, they used their average fan attendance and stuff like that that kind of could indicate other like factors of success and like how successful the team was in the past, and I'll show you that in just a second. And they also used an OLS regression model that was a lot more straightforward than the previous paper that we just talked about. So yeah, here's that. So as you can see here, the only performance-based statistics that were like on-field in-game statistics they used were ERA, which is earned run average per 9 innings or a full game, and they also used new runs, which was the number of total runs that they scored in 2011, which in this instance was the previous season, as they were trying to predict upcoming wins for the 2012 season. But other than those two statistics, they really went into just different statistics in general that aren't performance based. Like they had the average age of their batters, the average age of their pitchers. They had number of all-stars from the previous season. They had a binary variable for whether or not the team made the playoffs or not. They had a dummy variable for wins. And then they had a binary variable for whether or not they're having a new manager in the new season. I just thought it was super interesting that they used factors like this to predict success rather than on-field performance-based statistics. And then as you can see below the table, we actually have the actual model they're using, which as you can see is a pretty straightforward regression model. And you can see they have new runs, pitching age, whether or not the team made the playoffs, and total payroll, so like total team salary, regressed onto wins. So as you can see here, here are their results. Here's their predicted wins versus the actual wins that occurred during the 2012 season. As you can see, it was fairly accurate. There was a couple teams that were way off, but for the most part, it was pretty accurate. The authors seemed to think that they couldn't get the model to be more accurate due to unexplainable things that could happen in a given season, such as like a younger player just getting better because they get more experience. But they did find that the most successful teams seemed to have experienced pitchers, a recent playoff appearance, they scored a lot of runs, and they had a higher payroll. Yeah, so that's what they found in my second paper. Okay, so next let's talk about the research that I actually did. I'd like to start by going into a little bit of depth about the data that I used to come to my conclusions and results. So fortunately, I was able to find a database on the internet that contained almost exactly what I was looking for. It's called Lahman's Baseball Database. It's created by Sean Lahman, who's a well-known and well-respected baseball analyst within the baseball community. The database contained statistics for MLB teams, and it was for every team from 1892 to 2019, which was great because it provided us with a bunch of different data throughout like a huge period of time, which was great. Another thing that was great is that the statistics for each team contained relevant statistics for my research with pitching and hitting that were performance based, like batting average, hits, earned runs average, runs allowed, strikeouts, and stats like that. Now I'll show you exactly what the database looked like and each statistic that was in the database. So as you can see here, this is a summary of all the relevant statistics that I had available to me in my database. As you can see, there's statistics at the top like wins and losses, and then you have hits, walks, home runs, strikeouts, and other statistics like that. One of the things that was really great though was to see that I could balance out statistics between pitching and hitting. There was an even amount, but even more so, I could balance it out with like runs scored versus runs allowed to see like how that impacts differently since they're kind of polar opposites. So yeah, this is what I had available to me. I obviously didn't use all of these statistics in my model, which I'll talk about in a minute. But yeah, this is everything that I had available to me. It was a great database to use, lots of statistics, nothing to really complain about. Okay, so now on to methodology. So for my variable selection, obviously we wanted wins to be the dependent variable since we're trying to see whether or not batting or pitching is more important when it comes to winning games. But other than that, I tried to balance things out, and what I mean like that is I'd put in like opposite statistics. So say I have runs in there, for example, and I'd also balance that out with runs allowed. Since they're like polar opposite, I kind of wanted to see how that would affect things. But I'll get more into depth in that in a minute when I show you my model. But when looking at the coefficients after the regression was ran, I was mainly looking at three different things. I was looking at the sign, as in does a given statistic or variable positively or negatively affect wins. The magnitude, which is by how much does a given statistic affect wins, and whether or not a given variable is statistically significant. At the end, to determine whether or not batting or pitching was more important, I kind of just took all three of these into account, and I was like, oh, for example, pitching has more variables with larger magnitudes, and they have more statistically significant variables, so pitching must be more important to winning games. I'm not saying that's what my conclusion was, but I'm just giving a general example of how I went through my methodology and going through my regression. So here's the model that I actually ended up using. As you can see, I have wins as the dependent variable, and then I have 9 different independent variables, which are runs, hits, home runs, walks, strikeouts, runs allowed, hits allowed, home runs allowed, strikeouts allowed, walks allowed, and earned runs average. Now, as you can see, for almost all of these variables, I have them balanced, as in like I have the opposites. So I have runs, and then I have runs allowed, and then I have hits and hits allowed, and etc. and so forth. The only variable that I don't have like an opposite for like that is ERA. And I considered not putting ERA in there, but theoretically it just made too much sense to put it in there since ERA is such an important statistic for pitching and for the game of baseball. So that just made sense to me, and most of these actually ended up coming out as significant, which was great as well. So before I show you my results from my model, I'd like to give you a breakdown about how I was expecting my independent variables to behave with their sign, and just a little bit more context about them in general. So for runs or runs scored, I was expecting that sign to be positive, which makes sense because if you score more runs, your wins is expected to go up. I would expect it would have a positive effect on wins. Um, Same thing goes for hits and home runs and walks. You're getting runners on base, and those are scoring opportunities, so I would expect that that would have a positive effect on wins. Strikeouts, of course, I would expect would have a negative effect on wins just because that's a missed opportunity or a runner that's not put on base. It's essentially a failure. Runs allowed, hits allowed, and home runs allowed, and walks allowed, I was all expecting to be negative, which makes sense because those are all scoring opportunities that you're giving the other team. So of course I'd expect that those would all have a negative effect on winning. Strikeouts allowed, I of course thought that would be positive. That is recording an out and getting rid of another team's player, taking away a scoring opportunity for them. So of course I would expect that would have a positive effect on winning games. And finally and lastly, we have earned runs average, or ERA as it's called in the model. I was expecting that to be negative. If your ERA increases, that's you're giving up more runs, so of course I'd expect that to be negative because it's a stat you want to go down and be smaller, so I was expecting that to have a negative effect on winning games. And really quickly, before I show you my results table from Stata, here's just a breakdown of what all the initials you'll see in my table are and which variables they are. So R is runs, H is hits, HR is home runs, BB is walks, SO is strikeouts, RA is runs allowed, HA is hits allowed, HRA is home runs allowed, BBA is walks allowed, SOA is strikeouts allowed, and then of course ERA is just ERA. I'll leave this on screen for a couple extra seconds so you can look at it and make sure you know what you're gonna see when I show my results. So here's just a brief overview of my results. I'll show you the regression table that I ended up getting straight out from Stata in just a minute, but here's just a brief overview. So my model met the F-test, which was great to see and gave me a lot of confidence in it. All my variables passed the t-test and were significant, besides strikeouts, which I'll touch on in a little bit more in just a second. My model had a high R squared at 0.9290, which was great to see. That meant that my model fit the data really well. And even though strikeouts wasn't significant, it just made theoretical sense for me to include it in the model anyways, since strikeouts allowed was already included and it was significant, and strikeouts are a huge part of the game anyways, so it just made sense for me to keep that variable in there. Okay, so here's my results straight out from Stata. So when I was looking at this, I really was trying to pay attention to magnitude and see which independent variables had the most effect on wins. And right away, you'll notice that ERA had a huge effect on wins, which was something that was interesting to see. Um, Strikeouts was the only variable in here that wasn't significant, which was a little odd to me, but I do believe that it belongs, so I left it in the model. It also had a very tiny magnitude or impact on wins, which I thought was interesting. And going off of that, strikeouts allowed and walks allowed also had a very tiny impact on wins, if we're looking at their magnitude. And then the other two magnitudes that really only stood out to me were runs and runs allowed, and of course ERA. But it was interesting to see how those were really the only three variables to me that jump off the page with larger magnitudes than the rest of the sample or the variables that have been chosen. And this leads me to believe that pitching was a little bit more important than hitting. Not by much, obviously. I don't think anything here besides ERA really jumps out at me as huge. But seeing that runs allowed and earned runs average have the two biggest magnitudes out of anything else in this sample of independent variables, it does lead me to believe that pitching is slightly more important than hitting, but I don't think it's anything like too huge or definitive to say that pitching was way more important than hitting or vice versa. I really just saw it pitching slightly more important than hitting just based off of magnitudes of the largest magnitudes, I guess, of the sample. Okay, so to wrap things up, I'll get into a little bit of discussion about my recommendations and the limitations that I had in my research. So I did end up concluding that I believe pitching is slightly more important than hitting when it comes to winning games. So I would recommend when teams are looking to build up their team in the off season, I think pitching should be their first priority. And I'm not saying they'll like completely disregard batting, but I do think pitching should be the first thing teams build around. And I came to that conclusion just based off of the magnitude of the independent variables. There were only three variables that really stood out to me, and two of those were pitching statistics. And both of those pitching statistics were statistically significant. So I am confident in saying that pitching should be prioritized slightly over hitting, just a little bit. I mean, nothing too drastic, like I said. Some of the limitations of my study and research are the lack of sabermetrics and advanced statistics. Baseball is a very statistical heavy sport, and there's a lot more advanced and in-depth statistics out there besides the ones I used. So that's something looking back that I kind of wish maybe I had included a little bit more, is to include way more statistics that are more so advanced or could be considered sabermetrics. I also couldn't really find a way that I was comfortable to look into uncontrollable factors. Every season's different. I mean, I'm sure in like some given seasons hitting plays more of a factor to winning than pitching does, or you can't really control for factors like players unexpectedly getting better because they get more experience and things like that. So that is one of the main limitations of my work. But that's all from me. I hope you enjoyed watching me present my research and all the work that I've done the last 2 semesters towards my capstone project. Thanks for watching and have a great day.